Hello everybody, this is a presentation about connascence. So the motivation is basically to develop a metric for software design, and connascence can also serve as a theoretical foundation for software engineering. So this talk borrows a lot from Jim Weirich's talk about the building blocks of modularity. Unfortunately, Jim Weirich passed away some time ago, but he was a very prolific contributor to the Ruby community. He has given several presentations about the building blocks of modularity, so it's really worth checking out his presentation. Jim Weirich in turn based his work on a book by Melia Page Jones about object-oriented design, where he introduced this concept of coupling between different components of software. So connascence definition by the dictionary is the common birth of two or more at the same time, production of two or more together, that which is born or produced with another, or the act of growing together. And here's Jim Weirich's definition of connascence. So two pieces of software share connascence when a change in one requires a corresponding change in the other. So there are different types of connascence in software. And here's a list of connascence, different kinds of connascence ordered by increasing strength. So there's connascence of name. In terms of static connascence, there's connascence of name, connascence of type, connascence of meaning, connascence of position, and connascence of algorithms. There's also dynamic type of connascence. There are also dynamic kinds of connascence, which are connascence of execution, connascence of timing, connascence of value, and connascence of identity. You can also, for more information, you can also go to connascence.io, or a more recent website about it. So here's an example for connascence of name. So on the left side you have the function def sqr of x, which returns the square of a number. And on the right side you have a function call calling sqr twice. And obviously if you want to change the name from sqr to square, you would have to not only change the method name, but you would also have to change it on all call sites. So that is connascence of name. Another type of connascence is connascence of type. So here we have a method date to ISO string, which takes a datetime object and uses strf time to create a ISO string representation of the date. And in the second block, there's a method call to the same method, creating a datetime object and passing it to the method. And obviously, if you change the implementation of date to ISO string to use a different type of date object, the method arguments on each call site the types of those have to change as well. So this is connascence of type. Another type of connascence is connascence of meaning. So here's an order class with a status variable which gets set to true when ship order is called. And in another part of the code there's a if statement which says if order status equals 2, then print that the order was shipped. So this is a connascence of meaning because we attach a certain meaning to the number 2. There's also connascence of position. So here's an example of a method which accepts a file name and an image, and a corresponding method call passing a file name and an image. And obviously, if you were to change the order of the arguments, so the position of both arguments would change, you would have to do a corresponding change of position in all method calls, method invocations. So this is connascence of position. Here's an even stronger kind of connascence, which is connascence of algorithm. So, for example, in the first code block, we have a call to a password hash generating method, which hashes a password for safe storage. And then we have another piece of code which checks the password hash against, so it checks user input against the password hash. And obviously, these two pieces of code are connected by the algorithm used for hashing. So if we were to change it in one, if you would change the password generating method, you would also have to do a corresponding change to the password checking algorithm. So this is connascence of algorithm. Here's an example of a dynamic kind of connascence, the connascence of execution. Here we create an email object, then we set the recipient and the sender, and then we send the email. Then we set the subject, and obviously this is a problem because we should have set the subject before sending the email, which means there's a connascence of execution. You have to execute the method calls in a certain order. There are other kinds of connascence, like connascence of timing, where the timing of the execution of multiple components is important. Connascence of value, where several values must change together. And the connascence of identity, where multiple components must reference the same identity. So you already have seen the strength property of connascence. So strength is basically the difficulty of refactoring associated with each kind of connascence. And then there's locality. So if it's basically the closeness of the involved entities. So if it's same method is very local, same class is less local, same module is even less local, and so on. And then there's the degree of connascence. Degree is basically the number of entities involved in an instance of connascence. So if you have a lot of method calls to a single method, you have a high degree, for example. And one observation we can make is that strong connascence is okay if the locality is high as well. So it's not a big problem if you have a small method where the pieces of code have a high degree of connascence because you can all see them at the same time. So you're not likely going to miss one of the entities when doing a refactor. So what one can do is one can often transform a stronger kind of connascence to a weaker kind. So for example, if we have the order status example again with the number 2 meaning that the order was shipped, we can instead use a enum where we say new is 1, shipped is 2, and then we set the status to status.shipped instead of 2. And same again, if we check for order status, we compare with status.shipped and print the order was shipped. And in this case, now we have transformed the connascence of meaning to a connascence of name. We have transformed to a weaker kind of connascence. Another example for connascence transformation, here we have the connascence of execution from our email example. And instead of having separate method calls, we make a constructor which requires the developer to specify recipient, sender, and subject. And then the developer can add a call to method to email.send. And obviously now we don't have a connascence of execution anymore because it's not possible to do a wrong order of execution. Instead, you have a connascence of position. So you have to still be careful about the position of each argument, but it's a weaker kind of connascence. It's less problematic. So in conclusion, we can say, again, here's the definition from Jim Weirich's: two pieces of software share connascence when a change in one requires a corresponding change in the other. And obviously you want to avoid dynamic kinds of connascence. if possible, you want to transform strong kinds of connascence to weaker kind. If you can't do that, you want to increase the locality of entities with strong connascence. And vice versa, if you have a weaker kind of connascence or no connascence at all, it allows you to reduce the locality and make things more modular. And we can say that being aware of connascence helps design better and more decoupled systems. Okay, that's presentation about connascence. Thanks for listening, and let me know any comments or suggestions in the comments below. Thanks.